Okay, let's have a go at some more of these projectile questions now. And we'll start with the first one, which is question 6, part A. And this is about a military helicopter hovers 20 metres above a village whilst a soldier throws food an aid package to the ground, to the crowd below. The soldier throws each package with a velocity of 5 metres per second at an angle of 10 degrees below the horizontal. So part A is find the time it takes for the package to reach the ground, and well, let's do A part 1. So 6A part 1. Part 1. Okay, so as usual, it's not a bad idea to draw a little sketch. So we've got our helicopter is up at this height. The ground's down here somewhere, and a package is thrown at a certain angle, so it's going to be coming down like something like this. The initial direction at which it's thrown by the soldier is going to be at 10 degrees to the horizontal, and it's going to be with a velocity of 5 metres per second. So here's our package. It's going to be travelling at 5 metres per second, and this is going to be at an angle of 10 degrees below the horizontal, so that's 10 degrees. Okay, now we can resolve this velocity into its two components as usual. We are going to have a velocity in the horizontal direction, or the x direction if you like. That's going to be ux, because it's in the x direction, and that's going to be 5 cos 10 degrees. And it's going to have a vertical component of velocity uy of 5 sine 5 sine 10 degrees. So uy, which is 5 sine 10. Okay, now we're going to because we're interested in the time it takes to reach the ground, we're only going to focus on the vertical motion to start with. So let's consider the vertical motion. And I'm going to take the vertical motion with the vertical motion, which with downwards as positive. So I'm indicating that to the examiner that I'm going to choose downwards as positive. Of course, we've got our acceleration due to gravity is going to be acting down here. So this is acceleration A is 9.81 meters per second squared, and we know that our distance above the ground, where the helicopter is 20 meters. So we know S. When we come to using our Suvat equations, we know that this height is 20 meters. So as I've said already, we're going to consider the vertical motion first, and and we have so we've got S equals 20, vertical velocity uy, which is u, which is going to be uy in this case, is going to be 5 sine 10 degrees. The acceleration downwards, because I'm taking downwards as positive and the acceleration is acting downwards, don't forget we've got to the displacement downwards is 20 meters, the velocity downwards is 5 sine 10, and the acceleration downwards is 9.81. So these are all going to be positive quantities. So acceleration is going to be 9.81 meters per second squared, and we want the time, so we're going to use our usual S of all the Suvat equations that you want to use. We're going to use S equals ut plus a half at squared. Right, now when you plug in these values, we get S is 20, U is going to be uy, which is 5 sine 10. I'll leave that just as 5 sine 10. I'll tell you why, because I'm going to, at some point, I'm going to need to use the calculator, and I might as well put this all straight into the calculator without having to write out some enormously long decimal number that this comes to. So U is 5 sine 10. T is the thing we're trying to find. So T is the unknown, and A is 9.81. So we've got a half times 9.81 times T squared. Okay, now this is clearly a quadratic equation, okay? So these are the coefficients of T. This thing is the coefficient of T squared, and this is our constant. So let's write it, let's rearrange it so it looks like a quadratic equation. So I'm going to bring the 20 over the equal sign, and I'm going to evaluate 9.81 over 2, put that in, and when I do that, I'm going to end up with 4.9 T squared plus 5 sine 10 degrees. That's the coefficient of T, and because we brought the 20 over the equal sign, it's going to be minus 20 equals 0. Now you're not going to be able to factorise this, as you can probably have already figured that out for yourself, so therefore we are going to plug these numbers into the formula for the quadratic equation. So when you plug this in, you're going to get to the best of my advice anyway. So to 3 significant figures, the time it takes for the package to reach the ground is going to be 1.93 seconds. So if you've got that, well done. Okay, so that's that's the first part. Now if we go back to the question again, it says for A part 2, it says a villager catches the package at a height 2 meters above the ground. So find the time the package spends in the air. So if we look at the situation now, we're going to have our package is going to be thrown, but before it reaches the ground, it's going to be caught. So when it's 2 meters above the ground, it's going to be caught. And so we've got there's the ground, 2 meters. So this time the displacement, whereas before this is 20 meters all the way to the ground, but we're only going to go a distance of 18 meters till we reach this height above. This is the ground. So really, this is 18 meters. That's 20 meters. So you can see that what we do for this basically is we go back to the equation we had before. We go back to this equation here, which if I call that equation 1, and it's going to be, everything's going to be the same as equation 1, except instead of minus 20, we're going to have minus 18, because the height is only, the distance is only 18. So using equation 1, with S equal to with S equal to 18 meters, we're going to get 4.9 squared 4.9 t squared plus 5 sine 10 t minus 18 equals 0. Now when you solve this, you're going to get two values, and this leads to t1, which is negative, and we can ignore it, so it's minus 2.00. So we're going to ignore that. And we also end up with another value of t2 equals to 1.8300, which is the positive answer, and that's the one we're looking for. So the answer to this is now t equals 1.83 seconds. Okay, less than, and this is obviously less than this one because it's not travelled as far. Okay, so that's one of those types of questions that I personally dislike quite a bit because they're very messy, and we're not here interested in solving quadratic equations using the formula particularly. So, but there again, that's what is on the exam paper. That's what we've got to do. Okay, so now we're going to look at 6b, and this one, it says show that the food and aid package lands within 10 metres of the point on the ground directly below the helicopter. Okay, so this is part B, 6b, and we're interested now in the horizontal motion. So going back to our original diagram, we know that it was thrown out and travelled like this to the ground, and we know, if you think back, that we had initial velocity of 5 metres per second, and we resolved that into two components, 5 cosine 10 degrees, because don't forget this is 10 degrees below the horizontal, so this was 10 degrees. So 5 cosine 10 degrees was the horizontal component of this velocity, which we called ux. And that's what we're going to be interested in. We're not going to be interested in the vertical motion now, we're only interested in the horizontal motion. So we're going to consider the horizontal motion. So horizontal motion. We don't need to worry about acceleration now because gravity acts downwards. So our acceleration horizontally is 0. So horizontal motion, we know that acceleration is 0. What else do we know? Well, we know that it's got an initial velocity of 5 cosine theta. So u, in our Suvat equation, u is going to be 5 cos 10 degrees. And the initial velocity, in fact, and the final velocity is still going to be this. The velocity is just going to be continuously 5 cos 10 degrees all the time. Okay, there's no acceleration, so this is not going to speed up. So all the time, the velocity horizontally of this package is going to be 5 cos 10 degrees. The distance is what we want to find, and that's the distance from the point immediately under the helicopter. So we want to know what s is. So s now becomes this distance, a displacement s. So, and we're going to give that a positive. We're treating our motion to the right. All of these are going to be in the positive direction. So I'm just going to tell the examiner that I'm treating the direction to the right as positive. So A is 0, U is that. We know that the time, from the first part of the question, we know that the time it takes to reach, the time this package takes to come down to there is 1.933650 seconds. Okay, it's the same time. 937. No, sorry, 933. 650, etc. So we know the time, and we just want to work out the distance s. So the Suvat equation we're looking for is s equals ut. We're going to use s equals ut plus a half at squared. But when a is 0, this is going to become, that's going to disappear, and we're just going to get the s equals ut, u times t. So s is the horizontal velocity u times the time t. So if you plug u as 5 cos 10 degrees and t as 1.933, 650, etc. By the way, use you can't see it, can it? Use all of the okay, so horizontal motion, a is 0, u is 5 cos 10, t is the time that we got from part 1, and s equals ut, is 5 cos 10 times that. Notice that I'm not using the value that I found, that I wrote down to 3 significant figures. I'm actually using more significant figures in this calculation, and then I'll round it to 3 significant figures. So in that way, I'm not going to produce an inaccurate answer. Now when you work this out, it comes out to 9.521, etc. And all we need to show in this part of the question is that that it lands within 10 metres of the helicopter. So in other words, is S less than 10 metres? And it clearly is, so we can say it's less than 10 metres. So, yes. So we've shown that S is less than 10 metres from the drop point. Okay, so anyway, I hope that one helps.